Welcome back once again, my dear students. Today we are going to talk about membrane permeability. Although membrane permeability as such is not in your syllabus, but to understand the concept of osmosis, I feel the need that you are required to understand what is membrane permeability. So let's start with membrane permeability. Membrane permeability is simply defined as the degree of diffusion of molecules or ions across a membrane. Say this is a membrane. How much permeable this membrane is to ions and molecules, it constitutes it as membrane permeability. That is, the ease with which molecules and ions can pass through this membrane, it is known as it is membrane permeability. And on the basis of the degree of permeability, membranes can be categorized into the following four types. The first one is permeable membrane. Those membranes which allow both solute and solvent particles to pass through them, they are known as permeable membranes. Example is cell wall. They allow the easy movement of both solute and solvent molecules through them. Okay. Second type is impermeable membranes. Such membranes prohibit the diffusion of both solvent and solute particles through them. Example is heavily cutinized or subrized cell walls in plants. They do not allow solute and solvent molecules to pass through them. Okay. So the example is heavily cutinized or subrized cell walls in plants. The third type is semi-permeable membrane. These membranes are permeable to solvent but prevent the passage of solutes through them. Example is parchment membrane. Okay, they allow although the movement of solvent through them. Solvent can easily go through these membranes, but they stop the solute molecules to pass through them. Okay, they do not allow the solute molecules to pass through them, but they allow the movement of solvent molecules. Such membranes are known as semi-permeable membranes, and the best example is parchment membrane. Parchment membrane is actually the paper which is produced from untanned skin of animals. Okay, and finally the selectively permeable membrane or differentially permeable membrane. These membranes allow some solute to pass through them along with the solvent molecules. Okay, example is plasma membrane and tonoplast. Okay, say for example this is a selectively or differentially permeable membrane. It allows the movement of solvent molecules through it, and in addition to this it allows some selected solutes. Okay, it allows some selected solutes. Say this is a solute named as A and this is a solute named as B. This membrane allows solute A to pass through it, but it does not allow solute B to pass through it. Okay, so selectively or differentially permeable membranes are those membranes which, although select some ions and molecules to pass through them, they do not allow all the molecules, all the ions to pass through them. Okay, and they also allow the easy movement, the free movement of solvent molecules. Okay, so simply you can say that selectively or differentially permeable membranes are those membranes which, in addition to allowing the movement of water, allowing the movement of solvent molecules through them, they also allow some selected solutes to pass through them. Okay, these are known as selectively or differentially permeable membranes. Okay, so this is all about membrane permeability. I hope you all understand this. See you soon next time with a new lesson. Till then, stay blessed and thank you.